Hello, welcome back. So today we will solve chemistry, paper 41, October-November 24. Let's get started. Question 1 from the list of chemical and physical processes. Identify. State which of the processes A to H happens when an acid and alkali react. This is a neutralization, so it's B. Acid and alkali react to form salt and water. B reaches a position of equilibrium, that is reversible reaction. When an equation reaches equilibrium, the forward and backward reaction becomes equal. C involves particle changes from fixed positions to being mobile but still touching. So from fixed position, that means that is solids, to being mobile but still touching is liquid. So solid to liquid physical process, this is melting. C. These are physical changes. Melting is a physical change. The other physical change would be diffusion. B. And finally, this is caused by gas particles colliding with each other. Again, that would be diffusion. Because gas particles are colliding, they are moving from higher concentration to lower concentration regions. Define the term nucleon number. Nucleon number is basically the number of protons and neutrons that are present in the nucleus of the atom. Don't confuse neutrons with nucleons. Neutrons is neutrally charged particles inside the atom, while nucleon includes both protons and neutrons, which are present in the nucleus of the atom. Next, state the connection between number of occupied electron shells and the period number of that element. Now, period number basically tells us how many electron shells are there. If it's period 1, that means that we have one shell. If it's period 2, period 3, and we can know the number of occupied electron shells, so they are same. Periods are horizontal in the periodic table. Write the electronic configuration of the atom and ion. So 14, we have 14 electrons. 2. The innermost shell has 2 electrons, followed by 8 in the next one. 8, 9, 10. 4 are left. The third one can have 8 maximum, so 4 can fit. Then it's 17 minus. That means we have an extra electron, so we have 18 electrons. 2, 8, 9, 10, 10, and then 8. We got 18. Calculate the number of neutrons and electrons. Since this is a neutral atom, number of electrons and protons are going to be same. 11. Number of neutrons, 23 minus 11. That means we have 12 neutrons. 9 minus 1, this has an extra electron, so 9 plus 1, that makes it 10 electrons. Now, a very easy way is go to periodic table. Number of protons is 31. 31 protons. Where do we see 31? 31 is Ga, gallium. Gallium is to find the number of nucleons, we add protons and neutrons. 31 plus 38, you get 69. 69 on top. Number of protons is 31. To know if this is charged or not, we see if protons and electrons are equal. They're not. There is a deficit of 2 electrons. 2 electrons are less, so it has positive 3 actually. So this is positive 3. A sample of thallium contains 2 isotopes, TL203 and TL205. Define the term isotopes. Isotopes are atoms of the same element, but they have a different number of neutrons. The relative abundance TL203 and TL203 205 is in the ratio 3 to 7. Calculate the relative atomic mass of thallium. So we multiply the mass with ratio 203 into 3 plus 205 into 7. Now if this was percentage abundance, we would divide this by 100. But this is ratio. So we find the total ratio. 3 plus 7 equals to 10. Divide all of this by 10 and we get 204.4. That means if we calculate the average mass of this sample, we get 204.4, because in the sample some of them have the mass of 203, some have 205, but on average it's 204.4. Now suggest why these two isotopes have identical chemical properties. Because they have same number of electrons. Number of electrons determine the chemical properties, and number of protons help to identify the element. 3. Copper sulfate has the formula CuSO4. Aqueous copper sulfate is a blue solution. A sample of aqueous copper sulfate is made by adding excess copper oxide to hot dilute sulfuric acid. Complete the symbol equation for this reaction. Include the state symbols. We're adding copper oxide into sulfuric acid. Copper oxide is in powder form, probably it's a solid. And then we have dilute sulfuric acid. Acids are aqueous. That means that we don't say liquid, because liquids are just melted form of a solid. Aqueous are dissolved in water. SO4 copper sulfate is dissolved in water because all sulfates except lead, barium and calcium are soluble in water. Lead, barium, calcium, even mercury, but we don't usually get mercury, so lead, barium and calcium are soluble. So copper sulfate is soluble in water. That makes it aqueous. Here we have to write the missing element, which is H2NO, water. State 1 observation, which shows that copper oxide is added in excess. That is, no more solid dissolves. Copper oxide stop dissolving after it reaches the saturation point, and it starts settling at the bottom. It doesn't dissolve anymore. Describe how aqueous copper sulfate can be separated from the reaction mixture. So we have copper sulfate, and we have in this liquid, and we have a solid copper oxide which is not dissolved. This is not dissolved. This can be easily separated by filtration. Copper sulfate will filter out and the residue will be copper oxide. Crystals of hydrated copper sulfate can be obtained from aqueous copper sulfate by crystallization. State what is meant by hydrated. Hydrated is a substance which is chemically combined with water. It's not dissolved because dissolving is a physical process. We would say CuSO4 dot 5H2O. This is hydrated. These two molecules are chemically combined to each other. Substance that is chemically combined with water. Write the formula of hydrated copper sulfate. It is going to be CuSO4 with 5 water molecules. You should learn this. Describe how this crystallization is done. So we have a beaker, and we have aqueous copper sulfate. How can we obtain hydrated copper sulfate from this? By crystallization. So first is we need to add more crystals until saturated and heat it until saturated point. Heat until saturated point, and then allow it to cool. As it cools, crystals form. When you remove the heat, crystals start to form, and you get those crystals. These crystals if you want to get the sample of this, these can be filtered out, but this is not part of crystallization. Aqueous copper sulfate undergoes electrolysis using graphite electrodes. State why aqueous copper sulfate conducts electricity. Now, electricity can only be conducted when we have free moving electrons or mobile electrons. Mobile or free moving electrons. I hope it's clear. My handwriting is clear. Now, give 2 reasons why electrodes are made of graphite. So when there's electrolysis, why are these electrodes made out of graphite and not some other
reactive metal? Is because graphite is inert. If we don't want our electrodes to react with our electrolysis solution, they have to be inert so they don't react and they don't affect the products. And secondly, they should allow the movement of electrons. They should conduct electricity, because if they conduct electricity, the electrons will be able to flow through from the battery through the electrodes to the solution.
Describe how appearance of electrolyte changes during the electrolysis of aqueous copper sulfate. So in aqueous copper sulfate, that means we have CuSO4 and we have water. Cu plus 2, SO4 minus 2, H plus, OH minus. Now, to do this electrolysis, we need to memorize the reactivity series, which is mentioned here. For cations, let's look at the cation first. Cations, we have Cu plus 2 and H plus. Now, remember, the copper is less reactive, and in electrolysis, in these series, less reactive is favored at electrodes. So we get copper. So Cu plus 2 is reduced to copper, and the color changes from blue to colorless. Describe what is seen at the cathode during the electrolysis of aqueous copper sulfate. Describe what is seen at the cathode during the electrolysis of aqueous copper sulfate. So Cu plus 2 is changed into copper. So we get a solid copper is forming, and the color is pink. Pink in color. This is basically that copper is depositing at our cathode. Write the ionic half equation for the reaction at anode. And okay, now we have OH minus and we have SO4 minus 2. Again, less reactive are favored at electrons. We have OH minus and we have SO4. Again, least reactive is favored. So OH minus is less reactive than SO4, so OH minus would be favored. OH minus will go to the anode, OH minus, and it forms water, right? And oxygen. Now to balance it up, we need 4, 2, and 4 electrons. Now you might forget that which one is positive and which one is negative, which electrode and are positive and negative. So remember, pancake, anode is positive and cathode is negative. So anode is positive, so it attracts negative anions, OH minus. State 2 differences. If electrolysis is repeated using copper electrodes instead of graphite. If there was copper electrode, so anode will reduce in size, or anode will dissolve, and the color will remain constant, because as a Cu because more, and we will get a constant supply of more copper ions. Moving on to question number 4. When magnesium nitrate is heated strongly, magnesium oxide is formed. The equation for this reaction is shown. State the change in oxidation number of nitrogen in this reaction from dash to dash. So this is our nitrogen. Let's try to write it down here. NO3. Now we know nitrate is negative, right? So let's try to find out for the oxidation state of nitrogen. Nitrogen is X, Oxygen is -2. Let's write -2, and we have 3 oxygen, so we're supposed to multiply by 3. This equals to -1 because the overall charge is -1. So x plus, multiply them first, we get -6 minus 1. X equals -1 plus 6 equals to 5. So it changes from +5 to NO2. Let's try to find this. NO2. Now N is X plus oxygen is -2 multiplied by 2 equals to 0. The overall charge is 0. X plus -4 equals to 0. X equals +4. So it changes from +5 to -4. That means this was a reduction. Don't forget this trick, oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. So this thing is gaining electrons and is becoming less positive. Identify the element which is oxidized in this reaction. Let's try to start with magnesium. This is magnesium is +2, right? And we know for nitrogen was +5. Oxygen is -2. Here magnesium remains same, +2. Oxygen is -2. So it's not magnesium. It's a nitrogen. It's not, because +5 to +4 gaining electrons. Let's look at oxygen. So here oxygen was -2, and here it became 0 because it's a covalent compound O and O. This is always 0. When you have a covalent compound with both of them have same atoms, for example O2, like this, so the oxidation state is 0. So oxygen is oxidized. Now moving on, calculate the volume of NO2 gas at a room temperature and pressure formed when 7.4 gram of magnesium nitrate is heated. Use the following step. First, calculate the MR of magnesium nitrate. We have to go to the periodic table to calculate this. Magnesium is 24 plus nitrogen is 14. Oxygen is 16 plus 3 into 16. All of this multiplied by 2, and we get 148. So we get 148. Make sure to write them here, okay? Calculate the number of moles of magnesium nitrate used. The formula for moles is mass over MR. Mass is 7.4 divided by 148, and we get 0.05 moles. Define the number of moles of NO2 formed. To find NO2, we need to find the ratio between, because we have magnesium nitrate, and we need to find NO2. What's the ratio between both of them? 2 to 4. 2 to 4. So this is 0.05. What is the moles of NO2? We get 0.1 moles. Calculate the volume of NO2 of gas in centimeter cube. So the formula for volume is moles of gas is volume over 24, right? As we know that. To find the volume, we have to multiply 0.1, which is the moles of NO2, multiplied by 24, multiplied by 1000. Pick the smallest multiply, 1400 centimeter cube. Magnesium oxide MgO is an ionic compound. Complete the dot and cross diagram for magnesium oxide and give the charges on each of the ions. So magnesium is in, this is magnesium, It has 12 electrons and it is in group 2. That means it has 2 valence electron and it's Mg12. Mg12. Oxygen, on the other hand, is in group 6. It has 8 electrons. Now let's try to write it. 2, 8 plus 2, 10, 11, 12. For oxygen is going to be 2 and 6. Now magnesium is in group 2. Since it's in group 2, that means it loses 2 electrons. We give it a -2. Both of them are lost and we're left with 2 and 8. Because it has a deficit of 2 electrons, the overall positive charge is going to be +2. Let's try to draw it. 2 of them are already drawn and we have 8 more. 1, 2, 3, 4, 5, 6, 7, 8. This is +2, this is -2. It gains 2 electrons. Oxygen, on the other hand, gains 2 electrons. So this gets +2. The overall negative charge becomes -2 because it has 2 extra negative particles. Let's try to draw it now. 2 of them are already drawn. We'll draw 6. 1, 2, 3, 4, 5, 6. 2 more electrons that were lost from magnesium come to oxygen. These are +2. We have to draw them as a cross because they're coming from the magnesium atom. Oxygen is a covalent molecule. Complete the dot and cross diagram in the molecules of oxygen. To draw the covalent molecule of oxygen, we know that oxygen has 6 valence shell. It needs 2 more. So 1, 2, 3, 4, 5, 6. Let's try to draw. We'll have to draw these 2 here because these will be shared to get a total of 8 electrons. 1, 2, 3, 4, 5, 6, and here. Now let's try to count the total number of electrons for oxygen 1 and oxygen 2. 1, 2, 3, 4, 5, 6, 7, 8. So this is balanced. On the other side, 1, 2, 3, 4, 5, 6, 7, 8. Again, it's balanced. So this is correct. This is 2 pairs of electron are shared. So this is a double bond. Question number 5. Hydrogen is the first element of the periodic table. Hydrogen is used in fuel cells to produce electricity in vehicles. Name the substances which combines with oxygen with hydrogen in a fuel cell. Hydrogen combines with oxygen. Give one advantage and one disadvantage of using fuel cells of gasoline in vehicle. Now, in a fuel cell, hydrogen and oxygen are combining, so obviously the only product is going to be water. Water is the only product which is very environmentally friendly. No greenhouse gas such as carbon dioxide is not released. It's very good for the environment. But there is a disadvantage as well. There are multiple disadvantages. We can say that hydrogen cannot be stored in a regular box. It needs special containers. It's very hard to store. Other than that, in this day and age, we don't have a lot of hydrogen filling stations. It can be really hard to get access to hydrogen all the time. It needs to be stored at high pressure. If hydrogen is hard to store, we don't have enough filling stations. It's less efficient. It can be leaked out, and we need heavy tanks to store the hydrogen gas. Now, hydrogen gas can be made from petroleum by a 2-step procedure. The first one is that petroleum is separated into different components. This is fractional distillation. What happens in fractional distillation is that petroleum is heated and different components which are present in petroleum are going to be separated based on their boiling points. Step number 2, large molecules which are obtained in step 1 are converted into smaller molecules. This is known as cracking. Heavier molecules with a lot of carbon are broken down into smaller, fewer carbon molecules. Now, organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of ethyl ester methyl propanoate, this molecule, when 1 mole of ester methyl propanoate contains 6.02 times 10 power 23 molecules. Give your answer in standard form. First of all, we need to find the moles of our molecule. Mole of CH3, CH2, COO, H3, which is going to be mass divided by mR. Mass is 44 grams. What is the mR? We have to find the mR. mR is 12 plus 3 into 1 plus 12 plus 1 into 2 plus 12 plus 2 into 16 plus 12 plus 3 into 1, and we get 88. So 44 divided by 8, this is going to be 0.5. Now we need to find the moles of hydrogen. Moles of hydrogen inside this ester molecule. Now how many we know that the total moles for this molecule is 0.5 multiply by the number of hydrogen that is present in this molecule, which is 1 2 3 4 5 6 7 8. Multiply and you get 4. Now we can find the number of hydrogen atoms in this molecule. Here 1 mole has 6.02 times 10 power 23 molecules. So in 4 moles, how many molecules are present? That's why we multiply 4 times 6.02 times 10 power 23, and we get 2.408 times 10 power 24 number of hydrogen atoms. Now part D, for each of the homologous series, name a member that contains 6 hydrogen atoms. To do that, you need to know the general formula of each of them, which I've written here. Alkanes, it's CnH2n plus 2. We can try that with ethane. C is going to be 2. H is going to be 2 into 2, 4 plus 2, 6. C2H6, this is ethane. Alkene, the general formula is CnH2n. We can try with C3. You can try, if you don't get for the first one with 2 carbons, you can try with 3 carbons, 1 carbon to get 6 hydrogen atoms. 6 3 and you get H6. This is a 3 carbon, so this is propene. For alcohol, the general formula is CnH2n plus 1 OH. So we can try with ethanol, C2H4 plus 1 is 5. OH, 6 carbon, 6 hydrogen atoms are present. This is ethanol. And for carboxylic acid, this is a general formula. Let's try with C3. C3H5 COOH. This makes it propanoic acid. All of them have 6 hydrogen atoms. Unsaturated alkenes are converted into saturated alkanes by reaction with hydrogen gas. So just why alkenes and alkanes are hydrocarbons. The hydrocarbon is a molecule that has carbon and hydrogen only. As you can see above from the general formula, alcohols and carboxylic acid have oxygen as well, but alkanes and alkenes do not have any extra molecule. Suggest why alkenes are unsaturated. Now unsaturated, let me try to draw this here for this one. CC, this is ethane. On the other hand, I will draw alkene, which is, I'm drawing ethene. Now in alkene, we have a carbon-carbon double bond. That means this is not saturated with hydrogen atoms. Hydrogen atoms are less. This is why alkenes are unsaturated, because of their double bond. It is not saturated with hydrogen atoms. Name a catalyst to convert alkenes into alkanes. This is nickel. Explain why the conversion of alkenes into alkanes is an addition reaction, because we add nickel, hydrogen, and then in presence of nickel we get alkane. Only one product is formed. So this is an addition reaction. Hydrogen is added to our alkene to get an alkane. Natural polyamides are polymers made from amino acid monomers. State the type of polymerization that occurs when natural polyamides form. This is condensation, because to form them we have to remove water molecule. Condensation is reaction, water molecule is removed. In addition, when there's polymerization, the carbon bond is broken down and it reacts to the neighboring molecule. But in condensation, water molecule is removed. State the term given to the natural polyamides. So if the monomers are amino acid, a chain of amino acid is going to form proteins. An amino acid is represented as shown in the figure. Complete this figure to show the general structure of the amino acids. Show all the atoms and all of the bonds. Now CH, this is our group. This one. On the left side, we have to draw nitrogen, which is connected to two hydrogen atoms. On right side, we have a carboxylic acid, C double bond O, O and H. The remaining one is an R group. It depends on each specific amino acid. It is different for each of the amino acids. So we can write it that this is an R group. Now, 3 different amino acids are represented in figure 6.3. This figure. Complete the diagram in figure 6.4 to show part of the structure of natural polyamide that forms when 3 amino acids combine. Now, this is the condensation polymerization. So what happens is water is removed. H2O is removed like this. Same here. Water molecule is removed. And here water molecule is removed. Let's try to complete our drawing. Draw all of the show all the bonds again. This is going to be N. Okay, here. Look, if you see in this atom only OH is removed. One of the hydrogen is removed here. Same here. OH is removed here. So in total, a whole water molecule is removed from each of the amino acid. N, H, this is the other side. This is C, double bond O, and from the other side it's connected to nitrogen, and then hydrogen connected here. C, double bond O, N here is connected here. And then here on the other last we have C double bond O, a free bond. Don't forget to draw this bond, because this shows that this is going to be connected to the next amino acid and so on. This is not this one is a chain, so it's connected to, it has a lot of monomers. It is the part of the structure. E, a mixture of 3 amino acids are A, B, C can be separated, and the amino acid is identified using the paper chromatography. Complete the equation for RF value. RF is distance traveled by substance or solute, or a solute by substance divided by distance. Write the whole word, distance traveled by solvent. Now a sample of mixture of 3 amino acids is placed on the baseline here, and a chromatogram is allowed to develop as shown in figure 6.5. The finished chromatogram is shown in figure 6.6. The amino acid A, B, and C are colorless. Water is used as a solvent. Explain why the baseline is drawn in pencil. Because if it's drawn with pen has ink. It's also going to separate and show up results in the chromatogram and going to give us inaccurate results. So we use pencil. Pencil is insoluble in the solvent. State the type of substance used to make the colorless amino acid visible. It is called a locating agent. We spray it or apply it on our chromatogram and we can see the colorless amino acids which are separated on the chromatogram. Explain why in figure 6.6 only 2 spots are shown even though we use 3 amino acids. That means 2 amino acids have same RF value. So they cannot show different spots. Finally, suggest how the experiments can be changed to separate all 3 amino acids. So we have to use a different solvent because if we use a different soluble, it would have those amino acids will have different solubilities in that solvent. If it is very soluble, it's going to travel more. If it's less soluble, it's going to travel less, and it will show different spots on the chromatogram.